Well, hello again. I'm going to try to demonstrate to you how a buffer solution works. We're going to start with equal amounts of acetate anion and acetic acid, 0.25 molar each in 1 liter, so 0.25 moles of each. And we're going to add 1/100 of a mole of hydrochloric acid. We're going to make it in a quite small volume so we can assume that the volume doesn't change substantially. And in fact, the volume doesn't really matter that much. It's the base to acid ratio that actually makes the difference in the pH. The amounts are more to do with the buffering capacity. But in any case, we start out with 0.25 moles of each. We're going to add 1/100 of a mole of acid, and that's going to reduce the acetate anion. We're going to take a weak base, add a strong acid. They will react completely. Strong plus weak reacts completely. And so we will eat up all of the acid. We will convert 1/100 of a mole of the acetate to acetic acid. So we've taken a strong acid and converted it to a weak acid. That's sort of the essence of a buffer. Our initial conditions, pH, this is the Henderson-Hasselbalch equation, pK plus the log of the base to acid ratio. Since those are equal, that ratio is 1, the log is 0, so the pH is pK, which is 4.74 here. Okay, now we're going to add, well, we've added the acid, and we end up now with 0.24 moles of acid, 0.26 moles of base. And so once we add the acid, we're going to have our buffer equation, and we're going to have 0.24 moles over 0.26 moles. Take the log of 2426, that's going to be equal to 4.74, our pK, plus the log of that, which is negative 0.035. And so our pH is going to be equal to 4.71. So relatively a rather small change, 0.03 of a pH unit, which is actually what, 5 to 10% increase in acidity. But it's still, just think about it. If I have, let's just put a little side yard here to compare. If I take 1/100 of a mole of hydrogen chloride, HCl, let's see, hydrochloric acid in a liter, so that's 10 to the minus 2 molar, that's a pH of 2. So obviously the buffer solution, by taking that strong acid, using it up, and creating a weak acid using our existing weak base, we have a relatively speaking, quite a small difference in our pH. And that's the whole point of a buffer. Let's just say, rather than write it all down, if I were to switch this out and say, take my acid and add hydroxyl, 1/100 mole, these numbers would change. I would end up with 0.26 moles of acetate and 0.24 moles of acetic acid. This ratio here would be reversed, 0.26 over 0.24. So essentially, a negative log is a log of the reciprocal. So that sign would change, 0.035. And so I would add 0.035 4, give or take 0.03, 0.04, and end up with 4.74, 4.75, something like that. So a buffer resists a pH change in either direction. And that's all for this one here. See you later.